Assalamualaikum. My dear students, hope you are doing well by the grace of Almighty. Welcome to our NIEBS Home School. This is Marjia, Assistant Teacher of Science, National Ideal English Version School, morning shift. Now I am going to take a physics class for class 9 students. Our today's topic is reading done chapter 1. Our chapter name is physical quantities and their measurements. Reading done part 2. Now start our class. Our topic is physical quantities and their measurement. We all know that water becomes ice when it is cooled. It becomes vapor when it is heated. Peoples have been observing it from the very ancient times. This knowledge alone cannot be science completely, unless we can say at what condition and at what temperature water becomes ice after freezing or rising. The temperature at what condition and at what temperature does it start to boil and becomes vapor. This means in order to be science, everything has to be measured. The most important point of science is to be able to explain everything accurately after measuring them. This table name is 7 physical quantities in SI unit. This is very important. You have to know. Our quantity name is length, unit name is meter and symbol is m. Our quantity name is mass, then unit is kilogram and symbol is kg. Quantity name is time, unit name is second and symbol name is s. Quantity name is electric current and unit name is ampere and symbol is A. Our quantity name is temperature, unit name is Kelvin and symbol name is K. Our quantity name is amount of substance, unit name is mole, M-O-L-E and symbol name is mole, M-O-L. Our quantity name is luminous intensity and unit name is candela and symbol is CD. This is 7 physical quantities in SI unit. This is very important. You have to know. In this universe, anything we can measure is called a quantity. I repeat, in this universe, anything we can measure is called a quantity. In this physical world, there are innumerable quantities which can be measured. You can underline, in this universe, anything we can measure is called a quantity. In this physical world, there are innumerable quantities which can be measured. For example, we can name length, breadth, volume, weight, temperature, color, rigidity, position, velocity, internal material, electrical conductivity, non-conductivity, elasticity, heat conductivity, non-conductivity, density, specific heat, pressure, melting point, etc. And we, dear students, underline this part, length to etc. And we cannot finish this list. In brief, in the physical world, the quantities are endless. You may think that to measure this infinite number of quantities, we have to prepare the definition and unit for this infinite number of quantities. Actually, that is not true. You will be surprised hearing that and definitely be happy. If we can fix 7 units of 7 quantities, we will be able to calculate everything using these 7 units. Underline this line, we can fix 7 units of 7 quantities. We will be able to calculate everything using these 7 units. These 7 quantities are called fundamental quantities. When we express other quantity using these fundamental quantities, that is called a derived quantity. The fundamental quantities are length, mass, time, electric current, temperature, amount of substance and luminous intensity. Dear students, underline these lines. These internationally recognized 7 units of 7 fundamental quantities are called SI units. Underline this line. SI came from the French language term System International de Units, and these are shown in table 1.01 and table 1.02 shows are very big to very small quantities of distance, mass and time. Table name is very big to very small quantities of distance, mass and time. The distance distance nearest galaxy 6 into 10 to the power 19 meter, nearest star 4 into 10 to the power 16, radius of solar system 6 into 10 to the power 12, radius of earth 6 into 10 to the power 6. This distance is important. Radius of earth 6 into 10 to the power 6 meter, height of Everest 9 into 10 to the power 3 meter, length of virus 1 into 10 to the power minus 8, radius of hydrogen atom, this is also important, 5 into 10 to the power minus 11, radius of proton 1 into 10 to the power minus 15, this is important, and mass. Our galaxy 2 into 10 to the power 41 kg, the sun 2 into 10 to the power 30 kg, the earth, it is important, 6 into 10 to the power 24 kg, sheep 7 into 10 to the power 7 kg, elephant 5 into 10 to the power 3 kg, man 6 into 10 to the power 1 kg, dust 7 into 10 to the power minus 7 kg, electron 9 into 10 to the power minus 31 kg. This is important. We will use in many math. Electron mass is 9 into 10 to the power minus 31 kg. Now time and second. Big Bang time 4 into 10 to the power 17, dinosaur vanished 2 into 10 to the power 14, birth of human 8 into 10 to the power 12, single day 9 into 10 to the power 4 second, human heartbeat 1 second. This is important. For lifetime of moon 2 into 10 to the power minus 6 second, vibration of green light 2 into 10 to the power minus 15 second, vibration of 1 mega electron volt gamma light 4 into 10 to the power minus 21 second. Now our next topic is units of measurement. Among these units, second, meter and candela are defined before by some constant. For May 2019, kilogram, Kelvin, mole and ampere are also defined by some constant of physics. Now it is possible to measure all units of accurately using this constant in any laboratory in the world. Magnitude of fundamental constant, those are essential to measure. These 7 units are specified forever. The magnitude of 7 constant are shown in the table. This is the constant name, this is magnitude. The constant name is velocity of light. It is denoted by c. The magnitude is 2997992,458 meter per second. Our next constant name is Planck Constant. It is denoted by h. Its magnitude is 6.62607015 into 10 to the power minus 34 joule second. Our next constant is charge of electron. It is denoted by E. The magnitude is 1.60217776634 into 10 to the power minus 19 coulomb. This is very important constant. We will use in different math. Vibration of cesium. The magnitude is 9192631,770 Hz. Boltzmann Constant Kb. The magnitude is 1.380649 into 10 to the power minus 23 joule per Kelvin. Avogadro constant, it is denoted by Na. Its magnitude is 6.022140076 into 10 to the power 23 particles per mole. Our next constant name is luminous intensity. It is denoted by KCD. Its magnitude is 683 lumens per watt. New definition of these units. Our definition name is second. It is denoted by S. The time required to complete 9192631,770 vibration by cesium 133 atom is called 1 second. Our next unit is meter. It is denoted by M. In vacuum, the distance traveled by light in 1/299,792,458 second called 1 meter. Our next kilogram denoted by kg, the mass which is obtained by dividing Planck's constant by 6.62607015 into 10 to the power minus 34 meter square per second is called 1 kilogram. Ampere, it is denoted by a flow of 1 by 1.602176634 into 10 to the power minus 19 numbers of charge equivalent to charge of electron in 1 second is called 1 ampere. Our next one is mole. MOLE, it is denoted by MOL, amount of substance that contains 6.022140076 into 10 to the power 23 particles. Avogadro's number is called 1 mole. Next one is Kelvin. It is denoted by K, amount of charge of temperature with the charge of 1.380649 into 10 to the power minus 23 joules. Heat is called 1 Kelvin. Our next one is candela. It is denoted by CD. 1 candela is defined as the amount of 1 by 683 watt luminous intensity which is emitted by a source of light vibrating 540 into 10 to the power 12 cycles per second into 1 steradian solid angle. Now you should have a practical idea about how much is meant by 1 meter, what amount of mass is 1 kilogram, what time is 1 second, how much what is 1 Kelvin temperature, what amount of electric current is 1 ampere, what is meant by 1 mole substance, or what amount of light is 1 candela. Now let us try to give you that idea. Not only do you have to know it, but also you have to feel it. In general, it can be said that the distance from the feet to the stomach of a person of normal height is nearly 1 meter. I repeat, the distance from the feet to the stomach of a person of normal height is called nearly 1 meter. Our next one is the water contained in 1 liter bottle or the water kept in 4 glasses have a mass of nearly 1 kg. The time required to say 3 words 1001. I repeat, 1001 is approximately 1 second. Next one is, if 3 mobile phones are charging at the same time, 1 ampere electric current is used. A mobile is charged at nearly 5 volt. So current consumption will be 5 watt. If lights, fans, refrigerators of a resistance run at 220 volt and 1 ampere current is used, the power consumption will be 220 watt. Our next one is, if we can feel the fever of anyone by hand, it can be said that this temperature has increased by 1 Kelvin. It is difficult to understand a mole. We can say a large spoon filled with water contains 1 mole of water molecule. In 1 cup water, there are 10 moles. The light coming from a single candle can be said 1 candela. You see that none of them are perfect measurements, but easy to realize if you are habituated with this measurement. When in future you will calculate anything, then you will have to sense of proportion about it. Now our next topic is prefix. To study science or physics, we have to measure different things. Sometimes we need to measure the length of a galaxy 6 into 10 to the power 24 meter, or sometimes we have to measure the radius of the nucleus 1 into 10 to the power minus 15 meter. To measure this huge difference in the distance, it is not wise to use the same type of number. So internationally, some SI prefixes have been made. Due to this multiplier, we will be able to express a large or a small number by a small prefix. These prefixes are shown in table 1.05. In our daily life, we always use this prefix. To express distance, we say 1 kilometer instead of 1000 meter. I repeat, 1 kilometer instead of 1000 meter. We say 1 megabyte instead of 10 lakh bytes to express the size of photographs of a camera. Here the table name is the multiples and submultiples used in the SI units. Name deca, it is denoted by DA, and it is denoted by DA and its expression is 10 to the power 1. Hecto, H 10 to the power 2. Kilo, K 10 to the power 3. Mega, M 10 to the power 6. Giga, capital letter G 10 to the power 9. Tera, capital letter T 10 to the power 12. Peta, capital letter P 10 to the power 15. Exa, capital letter E 10 to the power 18. Deci, it is denoted by D 10 to the power minus 1. Centi, C 10 to the power minus 2. Milli, M 10 to the power minus 3. Micro, mu 10 to the power minus 6. Nano, N 10 to the power minus 9. Pico, P 10 to the power minus 12. Femto, F 10 to the power minus 15. Atto, A 10 to the power minus 18. Now our next topic is dimension. We already know that we already know that though there is an infinite number of quantities around us, we can measure them with the help of 7 units only. We have to know in which units a quantity can be expressed. Often we also need to know how this quantity is formed with which fundamental quantities: length L, time T, mass M, dimension mass M, etc. The power of different fundamental quantities in a quantity is called its dimension. I repeat, the power of different fundamental quantities in a quantity is called its dimension. For example, we will see next that force is the product of mass and acceleration. Again, acceleration is the rate of change of velocity with time and velocity is the rate of change of position with time. Therefore, dimension of velocity, distance by time equal to L by T, it is denoted by L T minus T. Dimension of acceleration, distance by time square, it is denoted by L by T square equal to L T minus 2. In this book, when we will speak about a new quantity, we will try to mention the dimension of it at the same time. You will see that this always will help you to understand the quantity in a different way. To indicate the dimension of a quantity in this book, it will be shown within third brackets. For example, force F is expressed as third bracket F mLt minus 2. Our next topic is scientific symbols and notations. The following method are followed to write the symbol of units. Number 1. To express the value of a quantity, first we write a number, leave a space after it and then write the symbol of the unit. For example, 2.21 kg. Next, 7.3 into 10 to the power 2 meter square or 22 k. The percentage sign also follows the same rule. However, no space is left after a number to write degrees, minutes, seconds. Number 2. Derived unit produced by multiplication is written using a space between two units. E dot G dot 2.35 Newton meter. Here is a space. Number 3. Derived unit produced by division is expressed as negative power or slash E dot G, a meter per second, or M slash S. Number 4. No punctuation mark or full stop is used with the symbol as they are mathematical expression but not the abbreviation form of anything. Number 5. The symbol of unit is written in a straight front. For example, M for meters, S for second, etc. But the symbol of quantities are written in italic or curved font. For example, M for mass, and V for velocity, etc. This is curved form M and V. Number 6, the symbols of unit are written in small letters, for example centimeter, second, mole, etc. But capital letters are used for those units which are taken from the name of scientist. N for Newton. If there are many letters in the unit, then the first letter will be capital only. The unit for the name of Pascal is PA. The prefix K, G, M, all are capital letter of units will be attached with the unit. M, W, Hertz with no space. It is important with no space. For example, kilometer, gigawatt, megahertz. Number 8, prefixes more than kilo, that means 10 to the power 3 will be in capital letter. Mega, giga, tera. These all are capital letter. Number 9, the symbols of unit will never be in plural form, not 25 kgs, always 25 kg. Number 10, we have to try to write any number or compound unit in a single line. A line break can be given between a number and a unit if it is really necessary. My dear students, I have finished today's part. Your homework number 1, make 5 MCQ from reading done part 2. That means today's part you make 5 MCQ for reading done part 2. I hope you have understood today's topic. See you again in the next class. Till then, Allah Hafiz.